Long March 3C, LM-3C. The Long March 3C, LM-3C carrier rocket is a three-stage cryogenic liquid-fueled clustered launch vehicle developed by the China Academy of Launch Vehicle Technology, CLT, based on the Long March 3A, LM-3A. Compared to the Long March 3B, LM-3B, it has two fewer boosters and eliminates the booster tail fins. Its overall structure is largely the same. The Long March 3C was China's first launch vehicle to employ a dual-laser inertial navigation system combined with satellite navigation guidance technology, improving the spacecraft's orbital insertion accuracy. Furthermore, the Long March 3C adopted the then latest high bitrate transmission technology in China, increasing data transmission speed and throughput during flight. This rocket is primarily used to launch geostationary orbit satellites, and has now officially entered the international commercial satellite launch service market. The development of the Long March 3C rocket began simultaneously with that of the Long March 3B, and joint training exercises were conducted with the Long March 3B at the Xichang Satellite Launch Center, XSLC, from March to May 1995. Originally, the Long March 3C was planned to launch the Sinosat-1, Agula 2, formerly ABS-5. In 2011, it was renamed ABS-3, and now L-1B satellites. However, due to a major accident during the maiden launch of the Long March 3B in 1996, these three satellites were relaunched using the Long March 3B to expedite the resumption of launches for this rocket model, and the development of the Long March 3C was suspended. Development resumed in 1998, during which time the design was improved, primarily by adding two tail fins to the first stage to increase the rocket's safety margin. Prototype development was completed by the end of 2000. The Long March 3C standard launch vehicle is 54.838 meters, 179.91 feet long. The first and second stages have a diameter of 3.35 meters, 10.99 feet. The boosters have a diameter of 2.25 meters, 7 feet 5 inches. The third stage has a diameter of 3 meters, 9.8 feet, and the fairing can reach a maximum diameter of 4 meters, 13.78 feet. The first and second stages and boosters use unsymmetrical dimethylhydrazine, UDMH, and dinitrogen tetroxide, commonly referred to as nitrogen tetroxide, and TO as propellants, while the third stage uses liquid hydrogen and liquid oxygen. Its standard geostationary transfer orbit, GTO, payload capacity is 3,800 kilograms, 8,378 pounds. The Long March 3C standard model is now retired. So, the entire rocket consists of the rocket body structure, propulsion system, control system, telemetry system, external measurement and safety system, propellant management and attitude control system during the coasting phase, cryogenic propellant utilization system, separation system, and auxiliary systems. Each booster is 15.326 meters, 50.28 feet long, with an oxidizer tank containing liquid nitrogen tetroxide at the top and a propellant tank containing liquid unsymmetrical dimethylhydrazine at the bottom. Each booster is equipped with a YF-25 engine, new version of the YF-20 engine, with a thrust of 740.4 kilonewtons, 166,400 pounds force, and the nozzle is fixed. The first stage is 23.272 meters, 76.35 feet long. The upper part contains an oxidizer tank filled with liquid nitrogen tetroxide, and the lower part contains a propellant tank filled with liquid unsymmetrical dimethylhydrazine, UDMH. The first stage is equipped with a YF-21C engine, which consists of 4 parallel YF-20C liquid nitrogen tetroxide UDMH engines, each with a thrust of 740.4 kilonewtons, 166,400 pounds force. The nozzle of each YF-20C engine can oscillate in one direction under the action of a servo mechanism to control the rocket's flight attitude, with a maximum oscillation angle of 10 degrees. The second stage is 12.92 meters, 42.4 feet long. The upper part contains an oxidizer tank filled with liquid nitrogen tetroxide, and the lower part contains a propellant tank filled with liquid unsymmetrical dimethylhydrazine. The second stage is equipped with a YF-22E engine, main engine, with a thrust of 740.4 kilonewtons, 166,400 pounds force, and one YF-23C vernier engine with 4 smaller nozzles and a thrust of 11.8 kilonewtons times 4 is equal to 47.2 kilonewtons, 10,611 pounds force. The main engine nozzle is fixed, while the vernier engine nozzle can swing in one direction with a maximum swing angle of 60 degrees to control the rocket's flight attitude. The third stage is 12.375 meters, 40.6 feet, long. The upper part contains a fuel tank filled with liquid hydrogen, and the lower part contains an oxidizer tank filled with liquid oxygen. The third stage uses a YF-75 liquid hydrogen liquid oxygen LH2 LOX engine, which has a second start capability. It consists of 2 independent single-tube engines connected in parallel, each with a thrust of 78.45 kilonewtons, 17,636 pounds force. Driven by a servo mechanism, it can swing bidirectionally, with a maximum combined swing angle of 4 degrees, controlling the flight attitude of the third stage rocket. During the rocket's flight through the atmosphere, the satellite fairing atop the rocket protects the satellite from various atmospheric interferences. The fairing provides a favorable environment for the satellite. The Long March 3C rocket satellite fairing consists of a nose cap, a double cone section, a cylindrical section, and an inverted cone section. The nose cap is made of fiberglass, offering excellent radio transmittance. The double cone and cylindrical sections are made of metal honeycomb material, while the inverted cone section is made of a chemically milled alloy. Radio transmittance windows and operational windows can be added to the cylindrical and double cone sections if needed. The Long March 3C rocket fairing is 9.561 meters, 31.368 feet, long, with a maximum outer diameter of 4 meters, 13.12 feet, and a maximum static envelope diameter of 3.65 meters, 11.975 feet. The Long March 3C rocket can provide various mechanical interfaces, but generally, it provides the standard 937B and 1194 mechanical interfaces. The lower frame of the satellite mates with the upper frame of the rocket's payload support and is locked in place by straps. The core stage Long March 3C enhanced version is lengthened by 1.488 meters, 4.88 feet. The booster is lengthened by 0.768 meters, 2.52 feet, and the propellant mass is increased by nearly 20 tons, 44,092 pounds. The Long March 3C2, LM-3C2 rocket, also known as Long March 3CE, LM-3CE, for export, is 56.326 meters, 184.8 feet, long and uses a 4-meter, 12-foot, diameter 4,000 F fairing, increasing its standard geostationary transfer orbit payload capacity to 3,900 kilograms, 8,598 pounds. On October 23, 2014, at the Xichang Satellite Launch Center, the Long March 3C2 rocket successfully launched the re-entry and return test vehicle for the third phase of China's lunar exploration program. It was an experimental robotic spacecraft, Chang'e 5T1. The Long March 3C improved 3Z launch vehicle is 57.126 meters, 187.42 feet, long, uses a 4.2-meter, 13.78 foot, diameter 4,200 Z type fairing, and has a standard geostationary transfer orbit payload capacity of 3,700 kilograms, 8,157 pounds. It can be used in conjunction with the Yuanzhong-1, YZ-1 upper stage. The Long March 3C carrier rocket can send satellites into geosynchronous transfer orbit. In a typical GTO mission, the first and second stages of the Long March 3C rocket first place the satellite and the third stage combination into a circular parking orbit. Then, The third stage performs a coasting phase of over 600 seconds. After the combination is reoriented under the control of the rocket's control system. The third stage engine ignites again to send the combination into the target GTO orbit. Finally, the third stage separates from the satellite. On April 25, 2008, at 23:35, China's first data relay satellite, Tianlian-101, was successfully launched from the Xichang Satellite Launch Center. This launch was the maiden voyage of this new type of rocket and the 105th flight of the Long March series of carrier rockets, bringing the Long March series to 63 consecutive successful launches since October 1996, achieving the world's highest consecutive success rate. On November 22, 2016, at 23:24, the Long March 3C Y-13 rocket ignited and lifted off from the Xichang Satellite Launch Center, successfully sending the Tianlian-104 satellite into its predetermined orbit. This was the 100th launch from the Xichang Satellite Launch Center, the 67th launch mission from the Launch Complex 2, LC-2 or LA-2, the 241st flight of the Long March series of carrier rockets, and the 160th launch from the China Academy of Launch Vehicle Technology, CALT. At 23:48 on May 17, 2019, the Long March 3C Y-16 rocket successfully launched the Beidou 2G8 satellite, replenishment satellite, into its predetermined orbit. This is the 45th Beidou navigation satellite, a geostationary orbit satellite, and the fourth backup satellite for the Beidou 2 project. This launch marked the 200th anniversary launch of the China Academy of Launch Vehicle Technology and the 17th launch of the Long March 3C rocket.